Hello and welcome to another series of inSynergie tutorials. In this little voyage we are to make with the system, we will see what's an inSynergie system capable of. What are the hardware modules that you can use? How do you program it? What software do you have to use to more or less everything? You are about to witness how this system can start with the smallest possible installation and overcome any difficulties to become the most complex system you can imagine, should you require it. One of the key points of inSynergie as a system is that it allows you to do all kinds of tasks, from a small office to a complete museum, a control room, more or less whatever you have in mind. I'm Miguel from inSynergie Rfid Reader, and we are going to see how do you do this. First we'll look at the hardware, then we'll look at the software, and we will see how do you go about programming the system that, as you can see, can be a very simple procedure that you can complicate as much as you want. We will do a little voyage through the different systems, different applications, and we will start a series of video tutorials that would allow you total proficiency with inSynergie system, as well as a way to know the products we have and what can we do for you in all kinds of installations and for mostly any control need you have. We will start discussing inSynergie hardware with one of its most basic modules, which is the iSMaster S. The iSMaster S is a small server meant for a small meeting room, an auditorium. It's for small and medium installations. It's actually extremely more powerful than it seems, and I've used it in quite complicated installations. But normally for things like a museum, a full control room, you use a system based on a bigger server, which is the iSMaster XL. Actually, the difference is mainly that this has a set of fixed ports that you may not need in a custom installation, which is why would you go for an iSMaster XL. But the iSMaster S is an extremely powerful system, which is based on this small rack unit. This has a Windows 10 inside. It's a Windows-based system. Actually, some people consider a Windows-based system as a disadvantage when it actually can be an advantage. The main reason for that is that if you lock a Windows system and you make sure that everything installed there is what it should be installed, it's actually extremely stable. With the added advantage that if you need to make any serious changes, especially hardware changes, and we see a lot in big installations in museums and things like that, let's say for example a power supply breaks, it's much easier to get components without having to need proprietary components. Systems are extremely stable, but it's also very good to know that when you have a problem, you can give it an immediate solution rather than wait for someone to react. Coming back to the system, this iSMaster S has, well, it's normally located in a rack, and here you have two ports where you can connect a keyboard, mouse, usually when you program it, or just quickly connect a USB stick to make a quick security copy of your installation. If we look at the back of the systems, we are going to see the ports, the input and output ports that make the whole iSMaster S connectivity. This is the power supply port. It's a secure power supply port. You normally do not need a secure power supply port if you have the system in a rack, but nobody knows what people can get to when they need to cable or change cables in a rack, so it's another layer of security. Here we have the connectivity for the main board of the system. This, well, actually this, you won't use much this, I haven't used it in years, for all keyboard and mouses, should you want to find another use to your keyboard connecting it to your server. Here we have two ports, which are part of the port scheme for control, the serial port that we will discuss in a moment. Have a VGA output, HDMI output. You can use both to connect to a screen. If you have the system connected to a screen, you do not need to have it, but normally if you have the system in a rack, I'd recommend connecting it to a screen, because there's something different about this system, and it's that it's very easy to change or add capabilities to the system, so it never hurts to have a monitor in the rack. Normally you would use DVI to connect to an HDMI monitor, but if you have an old monitor, you can also give it a use. You have two network ports to separate network interfaces, which normally are used. In one, you create your closed control system. Just you put on a switch and you connect any module that you need to connect to a network. For example, touchscreen module, PC control, relay over IP, RS-232 over IP, even KNX, whatever. Anything that's on the network can be controlled by inSynergie, and on the other you would use it to connect it to the internet, to remotely control or maintain the system, which is always a very good possibility. And you can make it with the two network interfaces. You also have two USB 2.0 ports and two USB 3.0 ports. We have modules that can connect via USB, and you can also use it, well, keyboard, mouse, memory stick, whatever. Have also an audio output this is not widely used because the system is usually installed in a meeting room or somewhere like that when you don't need sound for the system. It can be useful though if you want to establish some kind of audio signals, or you want some audio feedback on things that might happen on the system. Here we have 4 unidirectional RS-232 ports. There is a breakout cable that I'll show you that you can easily do. You have the pin out here, and with this you can control 4 peripherals unidirectionally. I don't use them much, mainly because I already have a good deal of RS-232 ports, to be precise, 7 RS-232 ports which are bidirectional, but if you have a lot of peripherals you want to control by RS-232, that's extremely useful. You can also add a matrix keyboard, which is, you can see here, which is a small 16-key keypad. That's useful if you want to make some simple actions at the touch of a button. It's not extremely common to install this, but if you have a room, you want to have this on the wall, and you want some very specific actions to be performed when you press one of the 16 buttons, it becomes very useful. It can be used also as a backup for lights or whatever, things you want to do easily, quickly at the press of a button, without connecting a touch interface or nothing really complicated. Next, we have the digital inputs, that's contact closure inputs. You need an external power supply for this, can be a 10 volts, 12 volts power supply. I'm very partial to using a 12 volts power supply for everything that needs to be connected around here, which I'll show you what it is. And it's useful for feedback from sensors, feedback from push buttons, feedback from switches, whatever you want that sends you a contact closure. Either there's voltage or there's not. These are 8 separate inputs for that. I use it a lot for sensors, for example, motion detector, presence sensors, even triggers for a heating system, whatever you can connect in here. And here we have relay outputs. Relay outputs, those are actually digital outputs, contact closure outputs, because you cannot connect more than 48 volts to those. You work externally for relays, which is also a good policy when you have a system, not to have mains relays in here. And essentially what they do is they switch on and off the control part of the relay when the external relay, which is what you use, is connected to the mains output. Those are, however, very useful for a lot of things, like, for example, opening and closing lights. I mean, we don't always use a system based on Dalibus, based on DMX, based even on analog outputs. We just use on and off for the lights. It's also very used to control motors, like curtains, screens. It's very common to control the screen with one of those. And well, in general, you have 8 relays for whatever you may need them. Here we have analog inputs. Analog inputs detect a range from 0 to 10 volts. You have a 10 volts output here, which, yes, you can bridge to give a signal, for example, to the inputs instead of using an external power supply. my advice would be to always use an external power supply, because I like to keep things modular, which is something in my philosophy that you will often see. And it's commonly used to detect for a thermostat from any kind of things that gives you a range, light sensor, heat sensor, things like that. And here we have the 8 analog outputs, which is commonly used for light dimmers or motors even. You have 0 to 10 volts motor in case you need variable speed, but that's extremely uncommon in the typical use of this system. But it's very typical when you have a small light system where you don't want to use Dalibus, you don't want to use DMX or any light system which is more evolved. You simply have some 0 to 10 volts dimmers and you control them using these 8 outputs, which kind of allow you to do the most common things in a room in quite a simple manner. And here we have what I call the legacy IR system. The legacy IR system is to control IR peripherals, such as a DVD, video recorder, if you have one in your museum. But this is extremely uncommon, mainly because the IR as a control means has a problem, which is it has no feedback. So if I turn on a DVD, I have no way of knowing if it's actually on or not. So that usually makes for an untidy control scheme, and nobody nowadays is using IR. Actually, you have to have it though, because there is some people that will want to trigger a DVD, for example, in a small meeting room. And here we have 6 serial control and a 7th here on the main board, which allows for the control of peripherals such as matrix switches, projectors, anything that uses serial control, RS232 control. Of course, nowadays we control almost everything through the network, and that's good. But it's not always the most secure option. I'm very traditional in that sense, and I like to control things by RS232. Why? Because I know I have a point-to-point connection, which is not tied to a network. I have an independent connection, which is from one end to the other. Usually what I do is whatever's on the rack, I control by serial. Whatever's far away from the rack, it's easier to control by network. Also, serial protocols are extremely developed and normally closed, so it's kind of easy to create a nicely working protocol using the serial ports. So I'm very partial to them. I actually like them, which doesn't mean I don't have installations where everything's on the network. It's more or less your taste, although I'd ask you to consider tradition in this case too, because I do like it, but it's more or less a matter of personal taste. This is extremely sturdy, and this is extremely useful in case you want to have an installation in a meeting room, for example. Well, I have one of those actually controlling some emergency control rooms, controlling video walls, matrices, and stuff like that. And it also becomes very powerful, because even if it's not an iSMaster XL, you can control all sorts of peripherals with it. This, for example, is a remote input, 16 inputs that are also POI, and you just plug onto the network and control from any place you want. Here we have something that we are going to see in the coming days. You might not think it's the most typical thing to have control to such a server as the iSMaster is, but this is an Rfid reader. And you'll ask me, why the hell do you want to control an Rfid reader from a room control system? Well, we're going to see that it has more uses than you can imagine. Because one of the things we have in the iSMaster is, and in general in any inSynergie system, is that it is extremely modular and extremely versatile. We can have this as a control central, but we also can have all sorts of things connected to the internet. We can have 10 of those in a building and connect them in a way that one server knows what's happening in the other server. You don't have to compile a code and download it to the system for it to work. The system is open code, which means that if I want to change a projector today, which I installed yesterday, I can do it in, let's say, 10 minutes. And it also has, apart from the capability to connect to an external interface, to connect via Ethernet, it has the capability to connect to a database. mainly any database you can find on the market, but it also has its own procedural database, which is MongoDB based, which allows you to do extremely complex interaction. We will see that when we discuss programming of the iSMaster S, but we can tackle extremely complex projects using this system. It can also communicate with WebSockets-based systems, or with any HTML system that uses WebSocket, which is extremely useful for some kinds of communications and very powerful when it comes to giving the system possibilities. In the coming days, we will see how you program this, and we will see how the inSynergie system can go from the most easy programming, which is done with mouse, to extremely complex interactions because of its logic power. Okay, this ends our first video tutorial for the inSynergie system of peripherals and control servers. Thank you everyone for watching, and in the next tutorial, for example, we will see how we can use the iSMaster S. We will see we will get a first look at the inSynergie system using the iSMaster S as base, because the system is very similar and you can go from there to more complex things and other servers. In another video tutorial, we will see how do you connect hardware to an iSMaster S, how do you connect a projector, how do you connect a network module, and in general, how do you establish an inSynergie system. Then we'll go into further programming problems until you are fully capable of programming any inSynergie system by yourself. We will also see why an RFID reader can be such an important component and often neglected in any inSynergie system, from a simple one to a very difficult one. Thank you everyone, and see you in the next tutorial.